Hello, everyone. My name is Jonathon Everatt. If any of you know me, you know my voice doesn't normally sound like this, and I know it sounds like I'm sick, but I'm actually Batman at night, and I forgot to switch my voice back. So if I get a bit too raspy during the talk, just let me know. So this talk that I did is DevOps or DevOops, securing a pipeline without losing your mind. And off the bat, we have some spoilers already. I may have lost my mind. So just a quick who am I? I'm that guy. I'm a proud dog dad. She's about a month old with me and older than that without me. I'm also a senior cybersecurity consultant at MWR. I'm the fluffiest bunny, and I know my dog likes bunnies because she likes me. I also think I'm funny, and this talk is up to you to decide if I am funny. I'm also very clumsy, and that falls into some other things. As you can see, I've already spilled coffee on myself, and I've only worn the shirt for like 2 hours today. So, some background for this talk. So, I had to create a DevOps pipeline as part of a crisis simulation exercise. So, what is a crisis simulation exercise, you may ask? Basically, we create a network, and the network is specifically vulnerable to a certain attack path. Then we execute the attack on that network with security tooling installed as it would be in the snapshot of a corporate environment. And then the incident response team will try and kick us out, basically. So, really good and really safe way for people to practice incident response in a way where if you lose, you're not getting ransomware across your entire environment. So this network had to work, firstly, very important. It had to be up, and it was up in AWS. And anyone who's worked with the cloud knows that cloud bills stack high and cloud bills stack fast. So I had to be very cognizant of not doing that T3 times 9 large instance and go crypto mining for my salary that month, because I wouldn't have a salary the next month. And then it has to look realistic, right? I can't have a GitLab repository with no commits in it. I can't have a domain admin emailing me their credentials. The attack path had to be realistic and it had to work. Fortunately, it didn't have to be working at scale. So what is this talking about? So it's kind of a day in the life of creating the crisis simulations and my learnings. I made a huge amount of mistakes doing this, and mistakes that other people have made and could have helped me not make this time. And I didn't ask for that advice. But I think it's fine to make mistakes as long as you're learning. It's also for a security professional like I am, a look behind the curtain, because it's very, very easy sometimes to recommend a security control that will make the thing secure, but doesn't think about how you're going to maintain it, how you're going to build it, how you're going to build onto it. So it's looking around the corner that making it work well, and making it safe aren't necessarily the same thing, right? Different professions have different perspectives, and everyone optimizes to something different from the other person. Obviously, we're building a DevOps pipeline, so there is some DevOps in here. And then also that security is hard, right? Because security is a balance. It's this balance between security and usability. Now, as AppSec lead at MWR, the most secure web app you will ever build doesn't connect to the internet, right? And the most usable web app you'll ever build doesn't ask for credentials to log in, but it's just usable in the wrong types of way. So it's very important to have a balance between security and usability. And this is something that can be very difficult to think from one perspective to the other. As a security professional, why is the person against doing a third factor of authentication logging in? Why not username, password, and phone and email, right? That's more secure, slightly more secure. And as another person is like, why do we have to do the third factor? We're going to lose users because it's not as usable. So finding that balance is really where you become an effective security consultant. And to find that balance, you have to live both sides, so to say. And so I dove right in. Sorry, Speako. I dove right in. Yeah, so there are some jokes in the slides, not that many. So some basics for the DevOps. It's basically write code, deploy code, get feedback, write more code, deploy more code in an infinite loop that never ends. There's a lot of advantages to it, but it's also very, very complex, and I cannot call myself to be a professional at it at all, because there's just so many technologies and so many different things that can go into it. But the main end goal is that you can quickly push code to new production and maintain it. So rather than being 6 months for that new DLC to come out for your favorite video game, they can add a new tree or a new bush every day or every minute or so. So it's really speeding up that development lifecycle. And there are a huge amount of ways you can do it. There are lots of technologies that exist for it. There really is a lot of them. But I had to choose three. It had to be a snapshot of a realistic corporate environment. And so I chose these three, right? I chose GitLab as my source code repository because I could install the code on GitHub. Um, and then on merge, it used Jenkins to build the code into a workable application, hopefully, and deploy it onto a Tomcat server. And that used NGINX to deploy that out to the internet, right? Not NGINX, as I thought it was for the first year that I read that word. We've all made that mistake before. So, and why I chose it, right? Well, firstly, this needs to represent a realistic corporate environment. So these technologies are common, and that's one of the reasons I chose them. I've interacted with them both before, right? I've used Jenkins and GitLab. It's basically RCE as a feature, and I've used Jenkins in CTFs, and I've used GitLab in other places. And then I also had some config files on hand for both of them from other projects. So I was like, oh, this will be easy. I've done some of the prep work. Those config files were useless. So we're going to start at the beginning with GitLab. So I had a plan, and as everyone knows, when you make a plan, you definitely stick to all of the steps and don't forget any part of it. So install a resource-constrained GitLab instance with Community Edition, configure it securely, create users and repositories, make many commits so it looks realistic, and we all know there's always a typo in there. So make sure to include only one typo because I like having no typos in my slides, and Cheryl sitting over there hates it when I have any typos anywhere. Then install everything else, then come back and make it work. But one does not simply get technology to just work. So first things first, download and install GitLab Community Edition. So as I said, there was a guide for creating a resource-constrained GitLab instance, and I went through the guide, and basically it said install Community Edition, and it should work. So I had a T3 medium instance, and I ran through the commands and see anything weird there where it says GitLab-EE. That's a typo in the documentation, I think, because if you just change that to CE, you download Community Edition. If you keep it at EE, it becomes Enterprise Edition. So yeah, they're trying to upgrade you even from documentation times. And it failed immediately out the gates. And I didn't know why, right? I had configured the host, I installed the GitLab, installation failed, there was enough space, I didn't know what the problem was. And then I did something crazy. I'm not sure anyone's done this before. I read the error. And what the error said is it said port 80 for HTTP traffic was closed, obviously because my AWS security group only allowed access from my IP. So I opened that up and it worked, right? But at what cost did it work, right? It did not fail. It did install. It was technically usable. It was just unusably slow, right? So when I said this has to work, it also has to work within a 4-hour exercise. I can't wait 3 minutes for every page to load. And that's what was happening here, right? And I was really confused because I had done everything. I'd mostly read the guide and it just said install GitLab. And I didn't know why it worked. So I went back to the guide and I realized, did I read the manual first? I skimmed it. We've all skimmed it. And I missed the only important step. And we all know we've done the same thing. Right? So just before I get into what that step was, I have a reminder for everyone. And that's you can always save yourself 10 minutes of reading with 5 hours of debugging. So I did not configure a swap file, and because of that, I did not have enough memory to actually run it properly. And it was the only thing in the guide that you actually needed apart from the installing part. And the manual actually has to be read to configure the swap file, but it's a common thing on Ubuntu that I actually didn't know of until this point. And without a swap file in my life, I can have no swappiness. So the swap file is a certain amount of space on a disk. It's about 8 gigs, I think I made it, which is basically really, really slow memory. Now, you don't want this on a desktop because your CSGO latency will be 200 before you send any packets to the network. But on a server, it does the job. And for my GitLab instance, it did the job great. It went down from 3 minutes to loading a page to 5 seconds, and I can survive 5 seconds. And remember, this just has to work. Network doesn't have to go vroom. And then swappiness, which is my favorite word going forward, is the percentage of memory that is used before it starts going over to the swap file. So once I had a swap file and I brought the swappiness into my life, everything was a lot better. Right? Now everything works at a usable speed, and I've installed GitLab, and that only took me 2 days, not that much time. So time for the next steps, right? We have to create users and we have to create repositories. And I only have access as the root user. And obviously, I would never create all my users as admin just to make my life easier. So when creating the users, there's some interesting stuff I saw. Firstly, who validates their GitLab account with a credit card? That feels like your admin's just trying to skim your card details from you. But also when creating an external user, you had to click external, which I saw after creating a few external users before clicking the button. Reading is not a strong theme for me, I see from this. And then I can proudly say I created all my users as regular users. I only made them admin on the repos. So now you can see here it's funky coders with an N. I have my external users, I have my internal users of Globex, but they still need to be given permissions and added to repositories. I think we ended up creating 20-something users at the end. And there's only one admin, so yay security, apart from the fact that I'm using the root account. We don't talk about that part. So I needed to create a few repositories because I've never seen a GitLab application with only one repository. Everyone starts that pet project, works at it really hard for about 3 hours, gives up on that pet project, and it sits in your GitLab for the next 5 years until you delete the application, you start again. They need to have commits in them, and the commit should have at least one typo. You know, I have to keep the theme going. And the merge requests should require approval because we are implementing security best practices here. Because if the merge requests don't require approval, if you compromise a single user, you can push code to production, which may be fun from a threat actor perspective, but remember making a mostly secure network here. And then the different users should have differing levels of access because by the principle of least privilege, we want to give them the least amount of privilege that they need to do their jobs. So I created my very safe project and immediately got to the problem where it's not public. I don't need it to be public, and I don't want it to be private because I don't feel like inviting everyone. So I can do it internally, right? That's a great idea. Except by default, and GitLab even says this in the documentation, if you have access to the network, you can sign up for a GitLab account. So if you make it internal, you're giving access to anyone who has access to your network, which we all hope is only our employees, but we all know can be a bit more than that. So I made this public because it needed to be, and I initialized my repository. Then I added users, and I clicked roles to add, and it gave me this. Now, I can see a guest, I know what a guest is, and I know what an owner is. So no privileges and all of the privileges, but I don't know where the spectrum in between is, right? And I don't have a high-level explanation of the difference between a developer and a maintainer. So where is the line drawn, and what do I need? So I went over to the documentation, and this time I actually read, and I immediately gave up on reading because it's terrible. This is not usable for me. I don't know if it's usable for you guys. If I'm looking for something specific, I love this. But nothing gives me a one-liner of a developer can generally do this, a maintainer can generally do this. It's all these check marks trying to work out exactly what privileges they have. So I gave everyone maintainer and owner. I understand why people have authorization problems now because I didn't want to go back and fix this later. So I said, oh no, I'll push it down the line. And it's funny how that even as a security professional, when it's a deadline, when you're working hard, when you're not thinking a lot, it's really easy to just push that down the line and say, oh no, it's not going into production yet, so I can deal with that later. Right? So there was technically a typo in the commits. I couldn't find a real one, so I'm very proud of that. But knowing my luck is probably in the big screenshot. Also, we never merged any branches. We just pushed straight to main. I know this probably causes a lot of pain for a lot of people, and I'm sorry, but it's just easier. And we all have to accept that if you don't have a technical control enforcing a branch to be created and someone else to approve it before it's being merged into main, it's not really a security control because threat actors are the lucky ones because they're the ones who can skip the bureaucracy of everything. So takeaways, read the manual because I already read the errors. The principle of least privilege is a great security control, but it can slow people down. And I need to understand as a security professional why people don't do it. They're not necessarily being malicious, they're just not necessarily thinking. And I will admit that at times I may not have been thinking. Best practices can only be supported by technical controls. If it's there in theory or through bureaucracy, it's not a security control, it's a hope. Default configurations are not the best configurations. Everything always needs to be configured properly. This includes your security products, and any options without explanations on them kind of becomes roulette, which one I go for. And then it's kind of funny how even when a security professional is building networks, they end up not being the most secure networks you see, because we then understand the issues everyone else has to deal with on a day-to-day basis. But now I have GitLab working, so I wanted to install Jenkins, and that is apparently called Jenkins cat, and I thought it was a really cool cat. So the initial plan was to boot on a Windows host, and this one I did delegate, and basically they said no. They came back and they said, we're not doing it, we're doing Linux. There were a lot of problems. We couldn't access it outside the host. We couldn't push the runner other places. And let's be honest, Linux is better. So new plan, we pivoted. So why pivot to Linux? Because Linux is better. It's a lot easier to configure. You have a lot more control. And I'm very comfortable with it because I use it on my day-to-day. If I used Windows on my day-to-day, it would probably be a different story there, right? Following the installation from there was quite easy, especially because we did the runner on the same host, which is a bad idea. Don't do it. And Linux just worked. So does that mean Linux is just better? Yes, it does. So why should the runner be on a different host? Well, security is a good reason. If you compromise a single runner, you only compromise that host. You're not compromising the entire Jenkins application. But another one is for testing, right? Fortunately, my application didn't need to work at scale, so I didn't need to test across multiple operating systems. But in real life, it does. So if I'm deploying a thick client to a desktop, I need to test it on Windows 7, 8, 10, 11, and that one person who still uses Vista. And yeah, so that's why you need runners on other hosts. I didn't do it. Scalability, cloud bills, a number of things, laziness. But it works now, right? Wrong. It's only installed. Unfortunately, I still need to do configuration, but at least it's installed. And this ended up being a lot less of a painful process than GitLab was, mostly because I delegated it. Now we need to configure it, right? We need to pull code, we need to build code, and we need to push code. And there also needs to be that golden threat of vulnerability, right? And I realize now that's a typo. It's meant to be thread. Sorry, Cheryl. But we still need that chain of compromise coming through, and that's just a theme I want everyone to remember as this goes. Also, where's the web server? So we went on a quick side quest, and we configured the web server. Now, this is a really interesting thing as to how you can see it's a difference when you've done something before. It's taken me 5 or 6 days at this point to actually configure Jenkins, configure GitLab, get things working. The web server took me 15 minutes. I've done it twice before. I knew exactly what I was doing. I ran my scripts, I ran my configs, and everything was just working perfectly. I had pre-compiled code that I knew worked from previous time. So I had my web app up and running within 30 minutes, and that's why this is only a side quest. Yeah, when you know what you're doing, it's quick. So back to the main quest. We need to configure a build script. We're back to those 3 steps: get code, build code, deploy code. But where do I put it, right? I know Jenkins' RCE is a feature, but where is the RCE to be a feature, right? So I saw something called Jenkins files, and I have no idea what they are. I have no idea how to configure them, and I don't have any on hand, so I ignored them. The web application has an RCE section, build config section, and I'm more comfortable with that, so I just configured the commands in the RCE section. I know it is called build config, I do promise that, but in my head, I've kind of done a match and replace rule for RCE at this point, so I'm just going with that. And so now we get our RCE going. Now, I'm going to give everyone a couple seconds just to look over that. There are a few problems there, and if you spot the problems, that's great. We'll talk about them later. So this seemed to work, seemed being the operative word there. We would build it, then I'd use SSH to deploy it to the web server. Why SSH, you ask? Because I know how to use SSH, and secures in the name. So pretty much good there. I also gave the admin of Jenkins control over the server because I pushed it with an SSH key to Ubuntu. Ubuntu on EC2 instances, for anyone who doesn't know, is by default can run sudo without a password because they don't have a password configured. So if you gain access to Jenkins, you gain control over the web server. And as a side note, the database, just because I was testing and the key now works there too. Yeah, but that's useful for lateral movement, so I'm going to leave that. And it works, and I need that vulnerable path. Now it's time for integration hell. So anyone who's ever built things separately and then tried to put them together, it becomes very, very difficult. And it is a complete pain. Everything immediately stopped working, right? And that's what it felt like. I tried to get the Jenkins build script to run, and it just didn't run. GitLab, I couldn't log in, but that's because I was typing the password incorrectly. Yeah. At least Jenkins could pull the boat. At least Jenkins could pull the code and build it. But I needed a prompt. How did it know when to pull the code, right? The web server was the only thing that was really tested and working. And when I say tested, I just kind of trusted that I'd done it correctly. So we're firstly going to do GitLab to Jenkins. Right, so what do we have? We have GitLab working, it stores our source code. We have source code in there. I didn't take you guys through the 89 commits we did because I thought that would be a bit boring. But if you really want, I can sit and run through each commit with you guys if you're interested after this talk. Jenkins works, we have our build script and we can push it to the web server. So that's great. We have the pieces there, we just need to put them together. And we need to build the puzzle. So how do we know when to build, right? So we either need GitLab to notify Jenkins, it needs to push the notification through, or we need Jenkins to pull the notification from GitLab. It needs to poll for that information, i.e. pulling it. Now, the person who had done it before me, Tinnis, our head of consultancy, said, hey, when you start setting up your DevOps pipeline, come talk to me. I have some advice on how to make it easier. And I didn't go talk to him. And so I spent 3 days trying to work this one out. Much later, we had the conversation about it, and he put the issue to me in detail, and I was like, "You're right. That's exactly what happened." But we ended up pushing the notification from GitLab simply because there's nothing worse, in my opinion, than you have your malware, you execute it, and you're waiting for that 30 seconds, that 40 seconds for something to finally poll and tell you you made a typo in the first word. Yeah, so we opted to do the push, was more reliable, and then we used the first option of a webhook that Jenkins let us configure. But wait, we went home first, because we do sometimes go home from the office, and we turned off the instances, because Cloud will stack high, Cloud will stack fast, and we came back and everything was slow. And when I say everything, I mean Jenkins, right? And we spent the next day debugging, and we had no idea what the issue was, and we were all stuck, so I delegated it off to our young protege, Ethan. And for the first time ever, somehow turning something off and on again actually made it worse. And then we worked out the issue. Because it's an EC2 instance, when you stop it and there's some time and then you start it again, it cycles IP addresses. Jenkins seems to do calls out to its own IP address, and we had configured it using its external IP. So by changing that IP, it became very, very, very slow. Not GitLab initially slow, but like 1.5 minutes, 2 minutes to even load a page. And so Ethan eventually came back to us, told us how to fix it, but I am incredibly disappointed in him for using Nano to fix it, because we both know, and we all know, Vim is the answer, Vim is the question, and Vim is our solution. But fortunately, by fixing the command he sent me and updating the configuration file to the new IP address, it worked. So we can get back to the normal issues we were having. So first, we had to create a webhook. So making a token is quite easy. The problem with the token, I now realize, is I hadn't created an authentication material or credentials specifically for that token. So we were getting authentication issues. And like every good debugger should, we ended up going all the way to Reddit, where we saw this post by this person here saying, "Oh no, just put your credentials in the URL. It will be fine." And so we put our credentials in the URL, and it worked. Security. The worst thing is that this actually works. And remember, we need that golden thread. So I'm going to use it. Yeah, now to prompt it, right? So we need a prompt on merge requests, which is great for my use case and terrible for security, specifically because I haven't configured it to be second-party approval. So any developer can go push code, approve their own merge request, and then push that malware straight to production. And a small problem for testing, I don't really know how to create branches at this point, because I've been pushing all of my code directly to main. So I kind of just ended up hitting the webhook specifically to test it. But yeah, so don't do this without the proper security controls in place. This is the kind of thing where you make it insecure, but by dumb luck, it's the wrong insecure for me to actually exploit. And then deploying from Jenkins, and I do apologize for white on green, that looks terrible. There we go. The code didn't work. I don't know why. Everything else was fine. The source code was pulled, a new WAR file was created. I even know this because I deleted the WAR file and then a new one was there. It was copied and deployed. The application would go up and the connection to the database would go down, and we don't know what went wrong. And we debugged for days, right? So let's take a look at the problems here. So this is where we were looking specifically at the build script, and you can kind of see the attitude we had. We looked at the build script as a whole, and we were like, well, firstly, we're using root credentials, but that can't be the problem because it means there's no authorization issues. Not a good idea, just don't do it. SSH does work because we can use it to laterally move. It's not a good idea to give admin control of production to Jenkins, but I mean, it works. And rm-r is extremely stressful, but it works, so we can just leave it. Nothing here should be stopping the build, and we were stuck, right? Except for one problem. We didn't actually compile everything. Now, for those who don't know, for Java, you go from a .java file to a .class file to a WAR file. And we then attack. Okay, that joke I think is funny. No, then we deploy the application. Our focus was too small. We were compiling the class files to the WAR files, but we never compiled the Java files to the class files. And apparently, the last time I had compiled the class files, the application was broken. So nothing was working. And we had rabbit holed so specifically on the WAR file not working, we never took the step back necessary to actually see the problem in the whole of looking at the whole compilation process of Java to class to WAR. Yeah, so we just need to recompile Java files into class files, literally 2 words, and then from there we can make everything work and bring it together with a touch of malware. Because what really is a crisis simulation without some malware? So what it needs to do, remember, we are in a crisis simulation, and the kind of attack path we thought up is compromised developer third party, some malware gets put into the Gitlab instance, which will then pull through into production, right? For production, we had Bizarre Bank because everyone wants to attack bank.com for some reason. I really feel sorry for those guys. Yeah, so we were thinking of a type of mage cards, right? And what MageCard is, it's a card skimming type malware where it'll pull the card details from the user's front-end browser and exfiltrate it to an attacker-controlled instance, right? And you can think of it as stored XSS, just with the injection point being through the GitLab instance. Ironically, this was the easiest part of the whole setup process because building the attack path was actually building the environment. Code doesn't know good from bad, and a lot of the time the difference between good from bad is use. It's like a threat actor's favorite tool is the tool you use that is effective, right? So it was quite honestly one message to ChatGPT fixing what they wrote to be our domain, and then we just sent it through and it just worked. Is that playing? Oh, cool. Okay, so you can see here we're logging in as our developer from Funky Coders, Ryan Smith. That is a very secure password, which I'll tell anyone who's curious. So this is a maintainer on the repository, and as a maintainer, he can go to settings, look at webhooks, and read our great, very secure webhook. The webhook worked, so we kept it. With that webhook, he's obviously now able to get the IP address, the internal IP address of the Jenkins host, and the admin credentials. You are meant to have credentials specifically for one user that can only build for that one code you're doing. Right now we log in with those very secure credentials, and you can see the mentality we had when we created that user because the password is installing Jenkins is hard. And once we signed in, we now have RCE on Jenkins, which is great because also in Jenkins has the root credentials for GitLab. Also in Jenkins has the SSH key that we can use to transition over to the web server. So we have everything here we need to go from VPN access to GitLab all the way to the production server through this golden thread of misconfigurations along the way. And you can see here, now we just read the SSH key, And this SSH key doesn't work, but you're welcome to try copy it out from the video to your specific device and then try SSH in. Let me know how it goes. And there's the key. Yeah. So that worked. That was the lateral movement part of it. We also obviously had the mage card part of it. We wanted the malware to come steal the data we needed so that we can make fraudulent transactions against bank.com. So here we have bringing it together with the malware. So we had pre-embedded the malware here because the idea was it's been compromised for a while. So we're going to see here a nice choice people had to make is we embedded it when we fixed SQL injection in the app. So if you want to roll back to before the malware was embedded, you're making a vulnerable app to SQL injection, which is a really nice catch-22 people got stuck in. And if you roll back to that, no one ever expects a SQL injection attack to come for some reason. But now you log in as your test account, you go to the card endpoint, and you see Internet Analytics is getting all of your card information. Now, I know analytics companies get a lot, but I don't want them to have my card data. And then with that, we are able to go make fraudulent transactions if it was real. Wait, that's the same slide. And it worked. Wait, play. Okay, I promise that's a video. So can we stop this? Not in the user's browser, it's a bit too late. That's the terrifying thing about attacks like cross-site scripting. Now, a properly configured content security policy could work. There's a small problem there. I've never seen a properly configured content security policy, so I've never actually tested it. The remedial actions need to be implemented sooner. That's why it's important to have practices like DevSecOps. That's why we should disable sign-up, why we should not have me giving privileges to people. You need security controls everywhere so that when it gets to the point where the attack's being executed, often that's too late to actually protect at that point. And then just some takeaways from this talk, and I promise no more memes. Okay, now no more memes. Oh, sorry, I need to click through. The stuff is hard, right? From all perspectives, it's hard. Everyone has challenges every day that we don't actually understand what they're going through. And when I see something that I'm like, that's so dumb, why would you do that in this application? I need to think back to my configured DevOps pipeline where I'm like, that's so dumb, why would I do that in that DevOps pipeline? If it works, it works. And at some level, that's a really good start for everyone, right? Security, workability, and maintenance all optimized differently. And I haven't even brought in the problem of scale yet. When you get stuck and mess up, it's okay. You don't need to go and do a whole talk about all the mess ups you made. But if you take a breath and you take a step back, you'll probably find a solution. And if you do get really stuck and someone has offered you advice, probably take them up on the advice. Even stuff that should work out of the box requires configuration. Never trust a manual, but do read it, do read it. Reading's important, trusting not so much. Trust but validate. Nothing out of the box is optimal, and that includes security tooling. I will repeat it again. The best EDRs I've seen are the configured EDRs, so please make sure you are configuring your things correctly and for use cases that make sense for your business. If you're a dev, if you're an architect, a security professional, or just anyone, try consider the other side when making recommendations, right? We are all working together to have technology work and be secure. But sometimes when you're making it secure, you can forget about the working part. And sometimes when you're making it work, you can forget about the secure part, right? That's why it's so important that when we all work together, we get the best solutions rather than when we all work separately or against each other. Or, hear me out on this one, we can destroy all technology and cybersecurity problem is solved. And most importantly, nothing is a waste of time if you're learning. Thank you for listening. Any questions? Also, that was like 75 slides, so let's go. Okay, perfect. Thanks, everyone.
Across the attack surface, scattered products and siloed views create blind spots that feel unstoppable. The deadliest risks are in these gaps, where attackers move in. It's time to unify fragmented snapshots into one all-seeing view of risk and unleash a platform born with one intention: isolate and eradicate your priority exposures. From IT infrastructure to cloud environments to critical infrastructure and everywhere in between. This is Tenable. Your exposure ends here.